All right, there are two types of cardiac cells, and we're going to talk about contractile cells. There's contractile cells and autorhythmic. And contractile cells these make up about 99% of cardiac cells. So we're going to talk about how they're going to respond, how they're going to contract. And when they contract, they are stimulated by an action potential. So what would you expect from the action potential of a skeletal muscle? Well, in a skeletal muscle, you would basically expect this type of thing. Right? So, you start at negative 90 or wherever, the low, negative 9, negative 70, whatever it is. You depolarize by sodium gates opening. You depolarize up to positive 30, and then repolarize, gets a little bit hyperpolarized, and then back to resting. Okay. Well, contractile cells do it a little bit differently. Contractile cells' resting membrane potential is at 90. And contractile cells depolarize when they're told to. Okay, there's no, waiting for sodium gates to open or whatever, and then it happens. And there has to be there's some kind of threshold, and then it happens. There's no threshold here. So in contractile cells, there's no threshold. So they just do what they're told to do. And as soon as they're told to do it, they do it. So in a contractile cell, the resting membrane potential is negative 90. And it comes out and it's just doing its thing, just sitting around. And when the action potential enters, because keep in mind that contractile cells have gap junctions, and they're going to pass along this action potential to each of these contractile cells. They're going to pass it along. So when they get it, they immediately depolarize. So they just depolarize. Okay, so the action potential, when the action potential enters, we'll call this 1. When the action potential enters voltage-gated sodium channels open, which should make sense. So this is 1. Okay, and once we get to positive 20, what happens? Well, what happens probably is what you were thinking happens. So basically what happens is some potassium channels open. These are fast potassium channels open, and of course, and these are voltage, excuse me. So those open, and of course, potassium leaves, and it starts to repolarize the membrane. Okay, but as that happens, we get something else occurring. And as that occurs, then calcium channels open. And calcium channels are, the calcium is from the outside, not the inside. So now we've got positive ions coming into the cell again, just like depolarization. So the Potassium channels are open, so those are coming out, but now we've got calcium coming in. And it creates this plateau effect. So it creates a plateau. And as that occurs, I'm going to put a little 3 here and a little 2 there, so you know where we are. But the potassium channels are open, or excuse me, the potassium channels are open, potassium's leaving, calcium channels are open, calcium is coming in, and that's causing this weird plateau. And then suddenly we get, try some purple here. So then we get slow potassium channels that open. And the slow potassium channels then cause repolarization. And then you still have the same thing here, and then back to resting membrane potential. So this area here is basically the refractory period. And it puts that contractile cell in kind of a holding pattern, because there cannot be another action potential in this refractory period. It's like an absolute refractory period. And it lasts about 0.25 to 0.3 seconds. Now, the heart rate, this refractory period is important because the heart rate, you can get a pretty high heart rate, but you cannot, or you should not, get a heart rate above about 220. So 220 beats per minute. At that point, if it's that high, there's no blood flow. Things kind of stop. That's kind of like fibrillation, okay? So in skeletal muscle, we can stimulate this skeletal muscle before it even relaxes. We can stimulate it to the point where it doesn't relax at all. Remember, that's tetany. And tetany is okay in a skeletal muscle, but it's not good in a contractile muscle. You don't want your heart going into tetany, because at that point, blood does not move. So where does the action potential even come from? Where is it initiated? So where is the action potential initiated? Well, it's initiated by autorhythmic cells. Rhythmic cells. So these are that 1% of cardiac cells that actually cause the action potential. So the next video, we're going to talk about how those guys work.